You think you know where you live. That's the first problem. You wake up every morning in a house, on a street, in a city, on a continent, on a planet orbiting a star. You have memorized your address. You can find your way home in the dark, and yet I am going to stand here and tell you that you are profoundly, almost comically lost, and that the galaxy you live inside, the one that has been above your head every single night of your life, is one of the strangest, most violent, most secretive structures in the known universe. We have been staring at it for 10,000 years. We named it after milk, and we are only in the last few decades, beginning to understand what it actually is. Let me start with something that I think about more than is probably healthy. Right now, at this moment, as you sit in this room, there is a black hole at the center of our galaxy. It is 4 million times the mass of the Sunday. It is 26,000 light years away, and it is, by the standards of such things, relatively quiet. Relatively, in the last decade, we photographed its shadow, the silhouette cast by its event horizon, against the glowing plasma surrounding it, and the image was exactly what Einstein's equations predicted over a century ago. That should make you stop. A man doing mathematics with a pencil in a room in Berlin in 1915 correctly described the behavior of an object he would never see in a galaxy he didn't fully understand, using physics that wouldn't be confirmed for 100 years. That is not a miracle. That is what real science does. And it is, I think, more astonishing than any miracle anyone has ever claimed. But here's what I want to push on today, because this is where most explanations of the Milky Way go soft on you. They give you the pretty pictures. They give you the spiral arms and the glowing core and the 100 billion stars, and the number is so large it stops meaning anything, and you nod along and go home and nothing has changed for you. I don't want that. I want you to feel the actual weirdness of this place. I want you to understand that the Milky Way is not a serene pinwheel of stars turning gracefully in the night. It is a churning, ancient, scar-covered system with a violent past, a strange present, and a future that will, in a few billion years, involve a head-on collision with the galaxy next door. This is your home. Let me actually show it to you. Start with the basics, because the basics themselves are strange. The Milky Way is a barred spiral galaxy, approximately 100,000 light years in diameter, roughly 1,000 light years thick at the disk, though the disk warps at its outer edges in a way that took us decades to fully map, and we are still not done. It contains somewhere between 200 billion and 400 billion stars. That range, 200 billion, give or take another 200 billion, should tell you something about how hard this galaxy is to count. It contains a comparable number of planets, and probably more. There are giant molecular clouds where new stars are being born right now at this moment out of collapsing hydrogen and dust and the recycled ash of dead stars. There are stellar nurseries. There are stellar graveyards. There are pulsars spinning hundreds of times per second, broadcasting radio pulses with a precision that makes our best atomic clocks look sloppy. And there is a halo. This is the part I want to spend some time on, because the halo is where things start to get genuinely strange in a way that should unsettle you. Surrounding the visible disk of the Milky Way, extending out perhaps 200,000 light years in every direction, there is a roughly spherical region that we call the stellar halo. It contains old stars, very old stars, some of them nearly as old as the universe itself. Population 2 stars with almost no heavy elements in them, because when they formed, the universe had not yet had enough time to forge those elements in the cores of earlier stars and scatter them in supernovae. These stars remember a time before the Milky Way was the Milky Way. They are archaeological artifacts. They are pottery shards from the first age of the cosmos. But the stars are not the strangest thing in the halo. The strangest thing in the halo, the strangest thing in the entire galaxy, arguably, is what we cannot see. Dark matter. I know you've heard of it. I know some of you are already bracing for either mystical oversimplification or mathematically impenetrable jargon. You're not going to get either one from me. Here is what we actually know, stated plainly. When astronomers in the 1930s, specifically Fritz Zwicky, a Swiss astrophysicist who was, by all accounts, difficult to be in a room with, but nearly impossible to be right against. When Zwicky looked at galaxy clusters and measured how fast their member galaxies were moving, he found they were moving too fast. They were moving so fast that by rights they should have flown apart. The cluster should not exist. The gravity of all the visible matter, all the stars and gas and dust, was nowhere near sufficient to hold them together. Zwicky concluded there was invisible matter providing the additional gravity. He called it dunkel materie, dark matter. And he was right, and the physics community largely ignored him for 40 years, which is a story I find myself thinking about every time I hear someone say that science is self-correcting and therefore obviously reliable. It is self-correcting. Eventually, the gap between the correction being available and the community accepting it can be a career, it can be a lifetime. Vera Rubin made it impossible to ignore. In the 1960s and 1970s, she and her colleague Kent Ford measured the rotation curves of galaxies, specifically how fast stars at different distances from the galactic center were orbiting. If most of the mass is concentrated in the center, as it appears visually, most of the stars, most of the gas, most of the light, then Newtonian gravity makes a clear prediction. Stars near the center orbit quickly, stars far out at the edges orbit slowly, just as Neptune orbits the sun far more slowly than Mercury does. That is what the math says. That is what the math has always said. That is not what Vera Rubin found. She found that stars at the outer edges of galaxies orbit at roughly the same speed as stars near the center. Flat rotation curves, not falling off with distance, flat. And there's only one explanation that works. There is an enormous amount of matter in these galaxies that we cannot see, distributed in a vast spherical halo, providing additional gravitational pull that prevents the outer stars from slowing down. The visible galaxy is embedded in and dwarfed by a halo of dark matter that outweighs the visible stars by a factor of somewhere between 5 and 10. The Milky Way, the thing you think you know, the thing you can photograph on a clear night in the mountains, is a minority fraction of the actual structure. Most of what this galaxy is invisible. Now here is where it gets strange. We do not know what dark matter is. I want to be precise about this because imprecision here is a form of dishonesty. We know what dark matter does. It gravitates, it clusters, it provides the scaffolding inside which visible matter, our matter, hydrogen and helium and carbon and oxygen and everything, you are made of clumps and forms, galaxies and stars and eventually life. The large-scale structure of the universe, those great cosmic filaments and sheets and voids that look, when you see the simulations, astonishingly like a neuron with its branching dendrites. That structure could not exist without dark matter. The simulations that include dark matter match the universe we observe with breathtaking precision. The simulations that leave it out are catastrophically wrong. We know dark matter is there the way you know a chair is there when you sit on it. But we cannot tell you what it is made of. We cannot catch it in a detector with certainty, though we have tried very hard and built extremely expensive machines to try. It does not appear to be any particle in the standard model of physics as we currently understand it. It is something else, something real, something structural, something fundamental, and we don't know what it is. I find this both humbling and intoxicating in equal measure. It is the kind of not knowing that should be kept alive, not resolved prematurely. And I say that as someone who spent a considerable portion of his life arguing against premature resolution of questions that deserve to stay open. Keeping the question honest is a discipline. Let me tell you about the center of the galaxy, because this is where the Milky Way stops being a quiet pastoral thing and starts being what it actually is. The galactic center is in the direction of the constellation Sagittarius, if you are in the northern hemisphere looking south on a summer night. It is invisible to the naked eye in optical light. There is too much dust between us and it, and the dust absorbs visible wavelengths completely. But in infrared light, in radio waves, in X-rays and gamma rays, the center blazes. It is dense with stars, so densely packed that if you lived on a planet near the galactic center, your night sky would never be dark. There would be thousands of stars brighter than Venus is from here, and the combined light would be bright enough to cast shadows at midnight. It is, by any measure, a different kind of place than the quiet suburban spiral arm where we live. At the very center is Sagittarius A star, 4 million solar masses, compressed into a region smaller than the orbit of Mercury around the Sunday. For most of its recent history, the last few million years, which in galactic terms is recent, it has been relatively inactive, consuming matter at a low rate, occasionally flaring when gas clouds or disrupted stars wander too close. But there is evidence discovered in the last 2 decades that things were not always so quiet. There are enormous structures called the Fermi bubbles detected in gamma rays, stretching 40,000 light years above and below the galactic plane. Like the exhaust plumes of some ancient engine, they appear to be the remnant of a period, perhaps 6 million years ago, when Sagittarius A star was consuming matter at a far greater rate, pouring energy into the galaxy around it. A quasar's activity, confined to our own backyard, erupting and then fading in the time between when our earliest ancestors walked on 2 legs, and right now, the Milky Way has a scar from that era. We are still mapping it. I want to talk about something that most textbooks treat as a solved problem, and which I think is still one of the most profound and underappreciated puzzles in all of astronomy. It is the question of how the Milky Way came to look the way it does. For most of my career, the standard picture of galaxy formation was essentially monolithic. The Milky Way formed from a single large collapsing cloud of gas and dark matter in the early universe, settled into a rotating disk, lit up with stars, and has been quietly evolving ever since. It was a story of smooth, ordered formation. Gravity plus rotation plus time, and you get a spiral galaxy. That picture is wrong. Not slightly wrong, substantially wrong. What we now know, largely from a European space mission called Gaia, that has been mapping the positions and velocities of over 1 billion stars with a precision that would have seemed like science fiction when I was a graduate student. What we now know is that the Milky Way is not a simple, smoothly formed structure. It is an assemblage, a conglomerate. It has absorbed dozens of smaller galaxies over its history, and those mergers have left fingerprints all over the stellar populations we observe today. The most significant of these mergers we have found evidence for happened roughly 10 billion years ago, before the thin disk of the galaxy, the disk in which our sun lives, had fully formed. A galaxy perhaps a quarter of the mass of the Milky Way, which we now call Gaia Enceladus, or the Gaia sausage, collided with the young Milky Way. The collision was not a gentle thing. It would have disrupted the early disk, scattered stars in chaotic orbits, injected enormous amounts of energy into the system. The stars from that ancient merger are still in the galaxy today. They orbit in highly elongated, inclined paths compared to the orderly circular orbits of disk stars. We can identify them chemically. They have a different mix of heavy elements than stars born in the main Milky Way, because their galaxy had its own history of stellar evolution, its own cycle of stars living and dying and enriching the gas with metals. They are immigrants, 300 million-year-old immigrants, orbiting through a galaxy that swallowed theirs. And we found them because we could measure the velocities and chemical compositions of over 1 billion individual stars and reconstruct backward what must have happened. This is worth stopping on. We took 1 billion stars. We measured individually where each one is, how fast it is moving, in what direction, and what it is made of. And from that, we reconstructed a collision that happened 10 billion years ago, before the Earth existed, before our sun existed. Archaeology at galactic scales. I have seen many extraordinary things in this field, and this one still stops me. Here is where it gets strange again. The sun itself is an immigrant, in a sense, or more precisely, the sun is a third-generation star formed from gas that was already profoundly enriched by two previous generations of stellar lives and deaths. The cargo in your body, the oxygen you are breathing, the calcium in your bones, the iron in your blood, these atoms were forged in the cores of stars that died before the sun was born. Supernovae exploded and scattered those atoms into the interstellar medium, where they mixed with hydrogen and helium and eventually collapsed under gravity to form new stars, including the one we orbit. You are, in the most literal and precise scientific sense, made of stellar ash, not metaphorically, chemically, physically, factually. The atoms of which you are constructed were synthesized in nuclear reactions in stellar interiors, ejected in violent deaths, and recycled across billions of years into you. I wrote about this in Cosmos, and I have said it so many times since that I am occasionally suspicious of my own sincerity when I say it again. But I want to say it again here because I want to say something that goes slightly beyond what I usually say, and I want to lay the foundation for it properly. If the atoms in your body came from dead stars, and those stars formed in the Milky Way from gas that was itself the remnant of even earlier stars, then the chemical history of the galaxy is written in your body. The ratio of iron to oxygen in your blood reflects the history of supernova rates in this galaxy over billions of years. The abundance of carbon, which is created in a particular nuclear resonance in helium-burning stellar interiors, a resonance that Fred Hoyle predicted must exist purely because life exists, which is one of the most audacious and successful pieces of reasoning in the history of science. The abundance of carbon reflects the specific nuclear physics of stars in this galaxy. You are not merely made of star stuff. You are a specific record of the specific history of the Milky Way. Your body is a paleontological specimen. Now, I want to talk about the structure of the galaxy in a way that I think is underappreciated and which connects to some of the deepest questions in contemporary physics. I want to talk about what the galaxy is doing over time. Not just what it looks like now, frozen in this particular moment of cosmic history, but what it is doing. The disk of the Milky Way is not a static object. It is alive with waves. Spiral arms are not fixed structures, they are density waves, regions where the gas and dust and young stars are compressed as they move through the arm like a traffic jam on a highway. The cars, the stars move through the jam, not with it. The arm itself propagates around the galaxy, and the material of the galaxy cycles through it. When the density of gas increases as it enters an arm, the pressure triggers gravitational collapse, and new stars are born. Clusters of hot, bright, short-lived blue stars mark the arms, precisely because those stars form in the arms and burn out before they travel far from their birthplace. The spiral pattern is a wave of star formation propagating through the galaxy. Our sun is not currently in a spiral arm. We are between arms in a smaller structure called the Orion spur, or the local arm, which connects the Perseus and Sagittarius arms. We live in a galactic suburb. The great bright arms of star formation are visible to us from a distance, but we are not in them. This has consequences. One of the proposed explanations for the periodic crises in Earth's history, the rhythm of mass extinctions, which has some evidence of a periodicity of roughly 30 million years, is that the solar system oscillates above and below the galactic plane as it orbits the galactic center, and that its encounters with spiral arms and the denser midplane periodically increase the flux of cosmic rays reaching Earth or disturb the outer solar system in ways that send cometary material inward. Whether this connection is real or spurious is genuinely uncertain. I would not overstate it. But the possibility that the galactic environment has shaped the history of life on Earth, not through fine-tuned precision, but through the brute environmental forcing of a galaxy, doing what galaxies do, that possibility seems to me worth taking seriously. The galaxy is not background scenery. We are inside it. It acts on us. I want to tell you something about a time when I was wrong. Not about the galaxy specifically, but about something adjacent to it that colors everything I think about the Milky Way and the question of life within it. For much of my early career, I was convinced and argued publicly and loudly that the number of technological civilizations in our galaxy was likely to be large. I worked with Frank Drake, who formulated the equation that now bears his name, attempting to estimate the prevalence of communicating civilizations. I thought the terms in that equation, the fraction of stars with planets, the fraction of those planets that develop life, the fraction where life becomes intelligent, the fraction that develops technology and chooses to communicate. I thought those terms were likely to give us a large number, not an astronomical number perhaps, but large dozens or hundreds of civilizations at least. I still don't know if I was wrong about that. And that uncertainty is, for me, the deepest one in all of this. Here is why it matters specifically to the structure of the galaxy. The Milky Way is 10 billion years old. The Sun is only 4.5 billion years old. For more than 5 billion years before our Sun formed, other stars in this galaxy were going through the same process of formation, planet formation, chemical enrichment that we went through. If life and intelligence are even modestly probable given the right conditions, there should have been civilizations in this galaxy billions of years before us. Given the modest rates at which interstellar travel seems theoretically possible, even with physics we understand today, a civilization that old could have, in principle, explored and colonized the entire Milky Way many times over in a time period that is small compared to the galaxy's age. And yet, we have no evidence, none, zero, of any other civilization in this galaxy. The sky is quiet. The radio spectrum is empty of signals that unmistakably originate from technology. We have been listening with increasing sophistication for decades. Nothing. This is called the Fermi paradox, after Enrico Fermi, who reportedly asked over lunch in 1950, "Where is everybody?" The question is real. It is not answered. And every year that passes, as our detection capabilities improve and the silence persists, makes it sharper. There are many proposed resolutions. Perhaps intelligence is extremely rare. Perhaps civilizations destroy themselves before they can communicate. Perhaps they are here and we don't recognize them. Perhaps the speed of light makes communication so slow that the galaxy is effectively fragmented into isolation. I do not know which of these, if any, is correct. I have thought about it for 50 years, and I am less confident of my intuitions now than I was at the beginning, which I take to be a sign of progress. What I know is this. Either we are cosmically alone, which is a staggering fact about the universe and our place in it, or we are not alone, and the silence has an explanation that we do not yet understand, which is equally staggering. There is no version of the answer that is not astonishing. There is no version that lets you off the hook. Let me come back to the galaxy itself, because I want to end with something that I think is the deepest hidden secret of the Milky Way, deeper than the dark matter, deeper than the supermassive black hole, deeper than the violent merger history. It is the question of what the galaxy actually is as a physical object, not its structure, not its contents, what it is. For most of human history, the Milky Way was simply the sky. It was not understood to be external to the Earth or a structure in space. The ancient Greeks called it Galaxias Kyklos, the Milky Circle. Some thought it was the path of heroes walking to heaven. Some thought it was the seam where two halves of the celestial sphere were joined. The idea that it was composed of individual stars was first seriously proposed by Democritus and confirmed by Galileo when he turned his telescope to it and saw for the first time that what appeared to the naked eye as a diffuse glow resolved into thousands upon thousands of individual stars. That was 1,610. Before that, humans had looked at the galaxy their entire civilization was embedded in and did not know it was stars. William Herschel, in the late 18th century, attempted the first real map of the galaxy's structure, counting stars in different directions and inferring the three-dimensional shape of the system. He concluded it was a flattened disk of stars with the sun near the center. He was right about the disk. He was wrong about the sun's position. The reason he was wrong is instructive. Herschel was trying to map the galaxy in visible light and the galactic plane, the densest richest part of the galaxy is precisely where the interstellar dust is thickest. The very disk he was trying to map was opaque to his observations. The dust blocked his view, and because the blocking was roughly equal in all directions from the sun's position, the galaxy appeared symmetric around us. We thought we were at the center because we couldn't see far enough to know we weren't. Harlow Shapley figured it out in 1918 by looking at globular clusters, those beautiful spherical collections of hundreds of thousands of stars that orbit the galaxy in the halo. Shapley mapped the distribution of globular clusters and noticed they were not symmetrically distributed around our position. They clustered preferentially toward the direction of Sagittarius. The center of the globular cluster system is the center of the galaxy, and the center was far away from us in that direction. We were not at the center. We were somewhere out in the disk, tens of thousands of light years from the center. This was the Copernican demotion applied to the galaxy itself. We are not at the center of the solar system, and we are not at the center of the galaxy, and we are not at the center of the universe. There is no center. Or rather, every point is equally the center, which is a deeper statement about the geometry of the universe than most people stop to appreciate. But here is what I really want to end with. Here is the thing that I find the most extraordinary, the most genuinely unsettling about everything I have just told you. We live inside this galaxy. We are embedded in it. The Milky Way is not something we can stand outside of and look at. We are inside it. The way a cell in your liver is inside you, it cannot see you, it cannot conceive of you, it exists within your structure without having access to the whole. And yet, using nothing but light that reaches us from our small corner of the disk, using the mathematics of physics, using the patient accumulation of observations over centuries, we have reconstructed the structure, the history, the contents, and the future of a structure 100,000 light years across. We have weighed the invisible matter that holds it together. We have found the echoes of ancient collisions in the orbits of old stars. We have photographed the shadow of the black hole at its center. We have discovered that most of what this galaxy is something we do not understand and cannot see. That last part, I want you to sit with that. 90% of the mass of this galaxy is dark matter. We don't know what it is. The galaxy we live in is 90% mystery, and the 100 billion galaxies beyond our own are presumably the same. The visible universe, everything that has ever shone, everything that has ever burned with nuclear fire, every star and planet and cloud and galaxy in every direction to the edge of what we can observe is a small foam of light floating in an ocean of something we do not understand. That is where we actually are. That is what the hidden secrets of the Milky Way ultimately point to. Not to answers that satisfy, but to a darkness that is literally dark. Dark matter, dark energy, dark history, a universe in which we are the first creatures, so far as we know, to have asked the question, and in which the question is so much larger than we are that I sometimes wonder whether we will ever see the bottom of it. And then I remember that we did not know the sun was a star until recently. We did not know the galaxy was a galaxy until recently. We did not know the universe was expanding until recently. Every generation has thought the great questions were nearly resolved, that the edges of knowledge were nearly mapped. Every generation has been wrong in the most wonderful possible way by discovering that the territory is larger, stranger, and more extraordinary than the map. So here's what I want to leave you with. Not a summary, not a comfort, a question. We have reconstructed the history of a galaxy from the inside, using starlight and mathematics and human stubbornness. We have found evidence of ancient collisions and invisible matter and a sleeping giant at the center. We have learned that the atoms in our bodies are the recycled ash of dead stars, and that the chemical history of the galaxy is written in our blood. We have looked at the center of our galaxy and seen the shadow of something 4 million times the mass of the Sunday. We have discovered that 90% of the galaxy is something we cannot identify with, the best instruments and the best physics we have. And here's what that means. If you take it seriously, not as metaphor but as fact, you live inside a structure whose nature you do not understand. which is itself embedded in a universe whose contents are mostly unknown, which came from a beginning whose cause is beyond our current physics, and which may be one of an unimaginably large number of universes, each with its own laws, its own constants, its own version of the story. The question is not whether this is scary. It is. The question is whether you choose to find that terrifying, or whether you choose to find it the most magnificent thing that has ever been said about what it means to be alive. That we are the method by which the cosmos has begun, haltingly and incompletely, to know itself. I am 60 years into this work, and I cannot tell you which feeling wins on a given morning, but I can tell you that I would not trade the question for any answer that had been handed to me without the looking. The galaxy is up there right now, above this ceiling, above this city. 100 billion stars turning around a black hole, 4 million times the mass of our Sunday, most of it invisible, all of it waiting. Go find out what it is.